So for this one, I'm going to go ahead and subtract the 3. 2x squared plus 9x plus 4 equals 0. Now, technically, if this is under the category where it says just solve and you can use any method, you could use quadratic formula, you could use completing the square, but trust me, factoring's a lot faster. And when you need to save precious time, you might want to factor it. So this one, if I go ahead and do my factor by grouping technique and I multiply these two, I'm looking for the factors of 8 that give me 9, and that's 1 times 8. So I could do 2x squared plus 8x. It doesn't matter if I put the 8 or the 1 first. I still get the same answer. And then I'm going to make my groups. And then I get factor out a GCF of 2x. I'm left with x plus 4. GCF of 1. And then now my factors are 2x plus 1 and x plus 4. I set each one of these factors equal to 0 and I'll solve. So 2x plus 1 equals 0 and x plus 4 equals 0. Subtract the 1. 2x equals negative 1. Divide by 2 and x equals negative half. Over here, I'll subtract the 4. X equals negative 4. So my two solutions are x equals negative 1/2 and x equals negative 4. Now again, you could have done completing the square or quadratic formula, but again, factoring's a lot faster, especially for the people who maybe guess and test. They probably didn't have to go through that whole factor by grouping thing. But again, you're trying to find what x equals. Next one, I'm also going to factor this one. Now, if you try to just divide by 6 and then square root it, you're going to miss out on one of your solutions. So you do need to set it equal to 0. So you do need to subtract the 3x, and you get 6x squared minus 3x equals 0. I'm going to factor out a greatest common factor of 3x. And then after I pull that out, what remains is going to be 2x minus 1 equals 0. I now set each factor equal to 0. So I would get 3x equals 0, divide by 3. My first solution is x equals 0. My second solution, I take the 2x minus 1, add the 1, and 2x equals 1, divide by 2, and my second solution is x equals 1/2. If you just try to divide by 6 and square root it, you really can't, because then you get an x on both sides, so you do have to subtract it over and factor out a GCF. Same thing on the next one.
Where did the 6x go down there? Oh wait, it went to 2x.
Right, I divided out the GCF. Let's see, here it is. All right, so this one again, it's already set equal to 0. I'm going to factor out a greatest common factor of 4. And I'm left with x squared plus 3. Again, I would take each factor, set it equal to 0. But notice when I set 4 equal to 0, there's nothing here to solve, so I don't need that. But I would set the x squared plus 3 equal to 0. Subtract the 3. X squared equals negative 3. I need to use the square root method. X equals plus and minus I radical 3. Good? Yes. Oh, I got to go back. All right, next one. Now, common mistake. Some of you are going to be tempted to FOIL this thing. Do not FOIL this thing. Just apply the square root method. If you FOIL it, it's going to get kind of messy. So all I'm doing is square rooting the left side, square rooting the right side. Square rooting that square causes the 2x minus 1 to fall out. I'm left with plus and minus the square root of 18. I need to simplify this radical. Okay, square root of 18, I can break it into 9 times 2. So I'm left with plus or minus 3 radical 2. Now remember, we are solving for x, so I need to isolate x by adding the 1. 2x is equal to 1 plus or minus 3 square root of 2. Divide both sides by 2. And x is equal to 1 plus or minus 3 square root 2 over 2. I have two solutions. If you want to pull them apart and write them as x equals 1 plus 3 square root 2 over 2, and the other one as 1 minus 3 square root 2 over 2, you can do that also. But I'm okay with you leaving them just like that because it has a radical there. Now these questions where I say CS, I want you to use completing the square. So again, this will be the only method that I will be requiring you to actually demonstrate. All the other methods would be up to you. So let's go ahead and complete this problem using completing the square. Notice again, this has a number in front of x squared. So my first step is to isolate or get rid of that 3. I need to make sure that the number in front of x squared is a 1. So divide everything by 3. I'm left with x squared minus 4/3 x minus 5/3 equals 0. I now need to do the next step, which is to move the constant. So I add 5/3 to both sides. Finish it up. Okay, so again, the step I'm completing here is moving the constant. So then I get x squared minus 4/3 x equals 5/3. I take the b term and I divide it by 2. So in this case, it's a fraction. So I'm going to multiply it by 1/2. I'm going to simplify diagonally here and I get negative 2/3. That's what I'm squaring and adding to both sides. So I'm adding 4/9. Over here I'm going to show.
If you left it, would it still be the same?
Okay, so I got to factor the left. So this becomes x minus 2/3 squared. I have to find a common denominator over here. So I have to add 5/3 and the 4/9. Common denominator is 9. I'm going to multiply this by 3 and this by 3, so it's 15 over 9. So now this gives me 19 over 9. I think they got like 76 over 9 if they didn't simplify. All right, so plus minus, because I'm square rooting. So now this becomes x minus 2/3 plus or minus square root of 19 over 3. I know it's getting kind of small here, but let me make it bigger. So now I'm going to move the 2/3 over. And I get x equals 2/3 plus or minus square root of 19 over 3. If you want to combine it all into 1, 2 plus or minus root 19 over 3. Either answer here. Next one also wants completing the square. So again, I can't have a negative x squared, so I have to divide everything by -1. So -1, -1, -1, -1. So it becomes x squared minus x plus 1 equals 0. I now need to move the constant. So I'll subtract it. I now need to take the b term and divide it by 2. So -1/2 squared gives me positive 1/4. That's what I'm adding to both sides. So in here I'll put the -1/2 squared. I now need to add -1 and 1/4. So I'm going to change the -1 into -4 over 4. And this gives me -3/4. This side I'm just going to factor and get x minus 1/2 squared. I'm going to apply the square root method. and I get x minus 1/2 is equal to plus and minus -3 over 2. I can simplify the -3 and pull out an I. And then move the half. So x equals 1/2 plus or minus I root 3 over 2. Again, if you want to put it all together with 1, 2 in the bottom, you can do that also. Pretty good? So again, I need to get rid of the 2, divide everything by 2, and I get x squared plus 5/2 x minus 4 equals 0. Next step, move the constant. X squared plus 5/2 x equals 4. Take the b term, divide it by 2. So 5/2 divided by 2 is really multiplied by the reciprocal, which is 2. And I get 5/4. 5/4 squared is 25 over 16. That's what I'm adding to both sides. I need to add these guys. So 4 over 1, 25 over 16. 16 is my common denominator. So here it would become 64. So when I add these, I get 89 over 16. So 89 over 16. And then I factor the left, x plus 5 over 4 squared. And then now I'll square root it.
Is 89 a prime number?
Yes. So then x plus 5/4 equals square root of 89 over 4. Move the 5/4. Now if 89 could have been broken down, you would, but we can't, so we won't. So x equals -5 over 4 plus or minus square root 89 over 4. If, again, you want to write it all in one, plus or minus root 89 over 4. Either answer is good. Next one, I'm still going to complete the square, but I'm getting rid of my fractions. I'm going to multiply everything by the common denominator, which is going to be 8. So I'm going to multiply this one by 8, this one by 8, this one by 8. So this would simplify and become 4x squared. This just simplifies and I'm left with 3x. And then this last one is 16. Now I'm completing the square. I could have moved it, but then I'd have to move it back.
You could just multiply it by 2. You know, because you can divide by 4 after.
Right, exactly. So we could have, like he said, we have to divide by 4. So now we divide by 4, we get x squared plus 3/4 x equals 4. All right, now I'm going to take that b term and I'm going to divide it by 2, so which is multiplied by 1/2, and I get 3/8. I square that and it becomes 9 over 64. That's what I'm going to add to both sides. Over here I'll show 3/8 squared just to help me factor. So this becomes x plus 3/8 squared. Over here I have to find a common denominator. It's going to be 256 over 64. And then I'll add these and I get 265 over 64. apply the square root method, and I get x plus 3/8 equals plus or minus the square root of 265 over 8. 265, I could divide it by 5, but there aren't any perfect squares in it, so I'm leaving it alone. So here I would get x equals negative 3/8 plus or minus square root of 265 over 8. Again, you could put it together with 1/8 in the bottom. Either answer would be acceptable. Just don't forget the plus minus. Next one is a FOIL question. This was section 1.3, where we had to multiply complex numbers. So here, square root of 3 times the square root of 5 is the square root of 15. Then outside, square root of 3 times I gives me I root 3. And then if I do inside, gives me negative I root 5. And then finally last, negative I times positive I gives me negative I squared. The only thing I can simplify here is the I squared. That becomes a negative 1. So I have negative negative here. No other radicals can be added, so I'm just going to leave my answer here as square root of 15 plus I square root 3 minus I square root 5 plus 1. And I'm done. For when you can't leave an I in the bottom, so we have to sort of rationalize it. So I'm going to multiply the top and the bottom by an I. So this becomes 3I. The denominator becomes 4I squared. Remember, I squared is equivalent to negative 1. So I'm going to change the bottom into 4 times negative 1. 3I over negative 4. If you want to move the negative sign out front, it doesn't really matter. Good. Next one is also a rationalized question. Okay, also keep in mind that for number 8, if you didn't want to multiply by the common denominator, right here you could have also multiplied the whole thing by the reciprocal, which was 2 over 1. You're still going to get it down to the same equation here. So multiplying by the reciprocal just to clear the fraction because we were completing the square, which is really what we should have done, is divide everything by a half, which is really multiply everything by 2. These complex numbers, I need to multiply this by its conjugate to make it disappear. So 1 plus 3I over 1 plus 3I. Remember, the conjugate is the same numbers that are in that denominator, but you change the sign. So if it was a subtraction, the conjugate's going to include a plus sign. I'm now going to FOIL both the top and the bottom. Remember, when you FOIL a complex number with its conjugate, all you really need to do is first and last. All right, so let's do the numerator. So if I go ahead and FOIL here, first gives me 1. Outside gives me 3I. Inside gives me 3I. And last gives me 9I squared. Now, I'll go ahead and simplify this thing right here, and then I'll put it in the top of the fraction. I can add the middle, gives me 6I. Remember, for the 9I squared, I'm going to change the I squared to a negative 1. So 1 plus 6I minus 9. And then here I can add, or do 1 minus 9, and I get negative 8 plus 6I. So this is my simplified numerator. I now need to FOIL the bottom, but again, when you multiply something by its conjugate, just do first and last. So 1 times 1 is 1, And negative 3i times positive 3i is negative 9i squared. Again, remember the I squared becomes a negative 1. And then negative 9 times negative 1 is going to give me positive 9. So my denominator is going to become 10. So now I have negative 8 plus 6i over 10, and I can simplify this. I can divide them all by 2. Final answer, negative 4 plus 3i over 5. This is from 1-1. This was from the linear, solving for x. I got to distribute, combine my like terms, move my letters left, my numbers right, or whichever way you want to move your letters. So distribute first. I get 4x minus 4 plus 5. Distribute the 3. 3x minus 9. Combine my like terms. So I get 4x plus 1. Over here I can combine my x's and get 4x minus 9. If I try to move my variables together, notice the variables are totally gone, and I'm left with 1 equal negative 9. This will never ever happen, so when this occurs and the variables cancel out, and you are not left with a true statement, this answer is no solution. You can also write it as the empty set symbol. Now, if what was left was 1 equals 1 or negative 9 equals negative 9, if it were a true statement, then that's when you get all real numbers. So remember from lesson 1, we either got one answer, x equals whatever it is, or all real numbers, or no solutions. You don't need to do any of the other contradiction, identity, anything like that. You don't need to worry about consistent or inconsistent. Just solve it and either tell me no solution, all real numbers, or whatever the number is that x equals. The next one is solving for a particular variable. Now we're not trying to get a number here, we're just rearranging and isolating the x. So the first thing I'm going to do is get my x's together. So I'm going to subtract 3x. I get ax minus 3x minus by equals negative 4z. I'm now going to add the by. And then now I'm going to get ax minus 3x equals by minus 4z. I need to factor out a GCF of x, and I'm left with a minus 3, by minus 4z. I'm going to divide both sides by a minus 3. That will cause x to be all by itself. And I'm left with by minus 4z divided by a minus 3. Final answer. Three more problems. Next one, we're just solving for x. Now, if you like fractions, you could distribute and, start combining your like terms. I'm going to multiply everything by the common denominator, which is 15, and clear my fraction. Multiply this one by 15 and this one by 15. This will become a 5. This will become a 3. So I'm going to distribute, instead of the 1/3, I distribute 5. So let me just show you what I'm distributing. So 5x minus 5 equals 9x minus 3. Move your letters together. Doesn't matter which way you move them. You're still going to get the same answer. Add 3. Negative 2 equals 4x. Divide by 4. And x equals negative 1/2. All right, so here we go. I to the 35th power. Now, there's different techniques, but the way that I taught you to do it is to take the power, divide it by 2. 2 goes into 35 once, 15, 17 times with a remainder of 1. So I'm going to break this into I squared to the 17th power, because remember, power to a power, you multiply. So right now I've got 34 i's taken care of, and I still need one more to make it to 35. Remember that I squared is equivalent to -1. When a negative number is raised to an odd exponent, the answer is negative. Okay? If that 17 were an even number, the answer would be positive. So I get -1 times I, and -1 times I is -I. Remember, on this part of it, all of the answers are either going to be 1, -1, I, or -I. Okay, so if you blank out, take a guess. Put one of those 4 choices. All right, but hopefully you'll know the procedure. Now, the next one, it's a negative exponent. So we're pulling back our review chapter stuff. Remember, when it's a negative exponent, you move it to the bottom of a fraction. And now I do the same process. So if I divide 46 by 2, I get 23. So this would be I squared to the 23rd power. I squared is -1. 23 is an odd number, so I get -1. So my answer is 1 divided by -1, and it's -1. And I'm done. So there are 16 more practice problems for you that we just went through, in addition to that huge review that you have to do, and the solution file is on Canvas. So when you come in tomorrow, make sure you bring a pencil, because my pencil sharpener is broken. Bring a pencil with a good eraser. 15 questions. Come in and be ready to work tomorrow. Any questions?